Hey, ladies and gentlemen. All right, today we've got a quick lesson here. For 10.5 and 10.6, we are introducing the quick way to work with scientific notation. I can write numbers in scientific notation or going backwards to standard form. So what I like to think about with scientific notation is essentially those numbers are either way too big or way too small for us to be able to work with normally. So we're going to use our knowledge about exponents to help us out. So it's got a base 10, so that's one of the key things. And if you remember our simple exponents, 10 to the 0 power, anything to the 0 power is really just a simple 1, so we are going to be using that possibly. And then we also have 10 to the first, 10 to the second, and so on. And then since we have small numbers, we're also going to be talking about negative exponents. So let's see what we got. So quick example, you've got 50 million. So working with that, and sometimes when we're talking about, let's say, like space stuff, distance between planets and so on, those numbers are so large for us to be able to write them out, it'd take a little bit longer compared to when we use scientific notation. Or, for example, when the numbers are so small, they might be able to be easier written with scientific notation. And if you notice what happened there, let me show you one more time, is we need to know where the decimal is located. So on a big number, our decimal is obviously at the back. And then for a very small number, the decimal will be at the front. We are simply going to be moving our decimal accordingly. So for example, if you notice, I have moved it 3 times, and then we keep moving it 6 times and 7 times. So one of the key things is really just counting how many zeros you have. Now we're not talking about the 0 at the very end, we're talking about your normal zeros, if you will. So since I moved it a total of 7 times, I'm going to be able to write it in scientific notation. Again, when I move the decimal, it is now changed to 5.0 times 10. So this is unfortunately a little bit elementary style with the x, but that's how they do scientific notation. Remember, it's a base 10 for our exponent, and since we moved it 7 times, we've got an exponent of 7. So again, 5.0 times 10 to the 7th power. This number here at the beginning part of your scientific notation has to be within this range. It has to be greater than or equal to 1, but it has to be less than 10. So I like to think about it between 1 and 9. That's probably the easiest thing for me. So 9.99999, that still works. It has to be a little bit less than 10. So if you can kind of remember between 1 and 9, I think we'll be good there. So when I'm moving to the left, I like to think about that's when I'm going to be getting the big numbers. So that's the positive exponent. But if I move the other direction, that's when I'm going to be getting some small numbers. So the way that I like to think about it again is, do I have a big number or a small number? And the big number is going to be classified anything greater than 1. So a 10, a 150, a 3,200,000. But a small number is going to start with 0. So it's like 0.005, something like that. So we're going to go ahead and just do a quick few samples here. Follow along the best that you can. Again, just like on that brief introduction, we need to know where the decimal is located. So obviously the decimal is at the back. And then I'm going to go ahead and count my movement. Now, if you remember on the previous one, I said it's counting the zeros. But on this one, that trick doesn't really work, because if I only count the zeros, I would really stop here. And I would write it as 687. But that doesn't really follow within the between 1 and 9 format. So really, we just keep moving our arrows to get it to 6 point something. Because again, it has to be between 1 and 9. So if I moved it correctly and I stop there, I'd have a 6.87. And I've moved it a total of 8 times. Since it's a big number, it's going to be a positive exponent. All right, going to go ahead and let you think about this one while I enjoy a nice sip of my black cherry vanilla bang. Yes, decimal is at the back. Remember, it's not just counting zeros, because if you just count your zeros, you might be a little bit off. 1, 2, 3. But if I stop there, it'd be 701. If I go one more, that'd be 70.1. Still not good enough. Aha, right there. So 7.01, and then again, count how many times you moved it. The nice thing is when you're moving it, you can be counting at the same time. So hey, look, we're teaching you how to count again today. You can do it. So we've got 7.01 times 10 to the fifth power. Again, positive exponent is the big number. So if you notice, we've got a small number here. We know it's a small number because it starts with your 0. That means I'm going to have a negative exponent. Still going to count. And I'm going to stop when it's between 1 and 9. 1 and 9. So obviously if I stop here, it'd be still 0 point something. So I'm really going to go to the 3. 3.25. So if I stop there, it'll be between 1 and 9. And again, I count how many times I've moved it. Negative 5. So my exponent would be negative 5. Again, I like thinking a small number is going to have a negative exponent. That's a little bit easier for me, maybe for you as well. Because sometimes students memorize which way I'm moving. Is it adding, subtracting, things like that. So again, my trick I like, big numbers, positive exponent, small numbers, negative exponent. All right, let's try another small number. And then again, the reason I know it's a small number is because it starts with a 0 point. So again, think about maybe a microscopic item that you're looking at, the thickness or the distance between it. 1, 2, 3. Moving it 3 times, 9.02 times 10 to the negative third power. Beautiful, beautiful. Now again, you're getting some practice on being able to write it in scientific notation, or now in the case standard form, so that when we actually start doing our problems, they're going to make sense to be able to convert it back and forth, so that when we're talking about either really large numbers or really small numbers, we'll be able to do our calculations. All right, so again, we need to ask ourselves, okay, where's my decimal? My decimal is currently visible at 3.201, obviously there. Now, if you remember, a positive exponent, I said, is going to be a large number. So if it's going to be a large number, I'm going to have some zeros at the back, and then I have to move my decimal. Now, the question may be, well, how many times do I have to move my decimal? And if you remember, it's connected to your exponent. So positive exponent means it's a big number. Exponent of 6 means I need to move it 6 times. So let's see. 1, 2, 3. Now I need to put some extra zeros there. 4, 5, 6. So I put my extra zeros. I've moved it a total of 6 times. Now I need to practice my elementary comma location. So if you remember the commas, it's counting by 3s. It's movement of 3s, so place value. So I really have a big number of 3,201,000. Hey, maybe that's the amount of YouTube followers that I'll get, subscribers, by the end of this craziness of life. Currently, I have like 98. It's going to be awesome. Oh, hopefully it's not a super small number, though. So if you notice, we've got a negative exponent, which means we're going to have a super small number, which means it's going to start with a 0 point something. Again, I asked myself, where is my decimal currently located? It's at the 8.14. But since it's a small number, I'm going to have some zeros in the front, because my answer has to start with a 0 point something. And how many times do I need to move my decimal? Well, again, looking at your exponent, we're going to move it a total of 5 times. Put some zeros in the front, or move and then put your zeros in the front. I need to move it 5 times. 1, 2, 3, 4, 5. You're going to put your zeros there, but don't forget about how it has to start. It has to start with a 0 point. And that 0 point doesn't really count for those spots there. So you put some zeros in the front, and then your final answer is going to be 0 point. And then you count, let's see, 1, 2, 3, 4. 1, 2, 3, 4. Yeah. Really small number. All right, think our last one or two. So again, big number because it's a positive exponent. Big numbers have the zeros at the end, like how many followers I might have, Maybe what my future bank account is. Probably not, right? So we're going to move it a total of 5 times. 1, 2, 3, 4, 5. Hey, that might be doable. $649,000. Not bad, not bad. And another small one. So you should be asking yourself, is it a big or small number? Negative exponent tells me it's a small number. How many times do I need to move it? Exponent's talking about 3, so I got to move it 3 times. So where my current decimal is, I'm going to move it 3 times to get a small number. 1, 2, 3. Put my zeros where they belong. And when I write my answer, it has to start with 0 point. So again, if you remember, you've got 2 zeros. So it's 0.0018. All right, beautiful. The next video that we're going to be doing is working with our actual operations. So now that we know how to work with scientific notation and standard form numbers, we're going to go ahead and apply some actual thinking. So I think we're going to start with adding, subtracting. Then the next video after that will be multiplying and dividing. So as you can see, our notes are done. You've got your assignment uploaded, and then you're going to go ahead and complete it and then upload your work for that as well. All right, be awesome, students. Have a great day.